we have Leanne Carrot, who is Executive Vice President of the Boeing Company and President and CEO of Defense, Space, and Security Boeing. She was named the BDS President CEO in February of this year, a $30 billion business that provides integrated solutions to meet the needs of defense, government, space, intelligence, and security customers in the United States around the world. And she has had a number of positions within the Boeing Company and on the way up the ladder to this august position she holds today. To her right, Dr. Arati Prabhakar, the director of DARPA since 2012, and as she was discussing just a little bit earlier, had previously been the director of NIST and has also served the nation in a number of capacities, also in industry and in venture capital. So she has a keen eye on some of those investment questions as well as her government job. To her right, Shahar Abouhazira, who is the CEO of RoboTeam Incorporated. I'm going to let him tell you a little bit more about RoboTeam when it's his turn to give some opening comments. They're an innovative company. They have facilities in a few different places, but including here in Gaithersburg outside of Washington. They've done some very interesting work on robotics with a couple of different Department of Defense customers and I think also some other government customers. And then to his right, Pierre Chow, famous, of course, because he's a previous director of the Defense Industrial Initiatives Group at CSIS, and what more could one hope for than that? But he also went on to additional good things. He's founding partner for Renaissance Strategic Advisors and the co-founder and managing partner of Enlightenment Capital, and brings tremendous perspective particularly on the financial side of defense investment. So we're going to start today with Mr. Kendall. If you could just give us kind of your opening thoughts on third offset strategy, what does it mean for industry and DoD partnership?
Yeah, let me set a little context, maybe that would help further frame some of the questions we'll get. The third offset is the phrase we're using to describe the things that we're trying to do to give us a substantial military advantage based largely on technology, but it also encompasses operational concepts and a number of other things. The need for a third offset strategy goes back to concerns that I've been talking about for a number of years now about challenges to our technological superiority. And if you've heard me speak, you've heard me say the following few sentences. Coming back into government after being out for 15 years, looking at intel every day, looking particularly at technical intelligence, and looking at the weapon systems that others are building with, to me, a very clear intent to deny the ability of the United States to project power. We have built a force, and we demonstrated dramatically in the first Gulf War the capabilities of that force, surprised ourselves even, that could wage conventional warfare far away very effectively against what at that time was a conventional force. Elements of that offset strategy, if you will, that we demonstrated at that time, what we now call the second offset strategy, included precision munitions particularly, but also stealth, network systems, and wide area surveillance sensors. So that suite of things was a leap forward, if you will, in military capability. And we have exploited that advantage for about a quarter of a century since then. We've enhanced it, we've built other systems, we've furthered some of those capabilities. But at the same time, potential adversaries have had a chance to understand and to design systems that are intended to defeat that capability. One of the facts about the military that we have is that it's dependent upon a small number of fairly high-value assets. They start with satellites, and then you go to aircraft carriers, forward air bases, a few logistics nodes, command and control nodes. And if you can successfully target those things, then you basically deny us the ability to project power. So the whole idea of anti-access area denial is built around that. And the systems that are being built by others include their own precision munitions, usually delivered by land or air-launched cruise or ballistic missiles, surveillance systems that support them, and fairly sophisticated techniques to penetrate our defenses in some case. So we are back in a situation where we need to be competitive. We need to do more to ensure we retain an advantage. As long as I've been involved with the military, which goes back to the 70s, 60s even, the United States has enjoyed an advantage based on technology. And we're concerned about the erosion of that advantage and the challenge to it, coming from both the other major powers that are, you could regard as near-peer competitors, Russia and China in particular. But some of the technologies that I just talked about, the ability to attack our high-value assets, will proliferate. They're proliferating now. So even countries like Korea and North Korea and Iran pose a threat to us. So that's the genesis of this. And I've been talking about this for several years. We've taken steps earlier on. We took steps when Secretary Carter was in my position. We took steps when he was the Deputy Secretary to address this problem. When Bob Work came in, his notion of a third offset strategy was something that animated us. Arthi and I and Bob and others worked over a summer with him to kind of come up with some ideas. And out of that came partly automation and artificial intelligence and its use to enable capabilities. The idea that we should be able to operate from greater range so that the things that are being built to defeat us are less effective. We just move further back and we were able to counter them from further back. And also the idea that we move away from reliance on such a small number of very expensive and high-value assets to more distributed capabilities that are harder to target and prevent a much more difficult problem for the adversary. And you do that by getting economies in manufacturing in part, so you get quantity at cost. So those were the elements of it. We've been emphasizing the artificial intelligence autonomy part of that, but the other pieces matter too. And we did a study called the Long Range R&D Planning Effort, which is modeled on an earlier effort to try to identify some specific applications of those sorts of things that would help. Steve Welby led that for the department. It led to a lot of the things we put into our 17 budget in particular as demonstrations. So we've also done a number of other things. There are a lot of pieces to this. There's a widespread efforts on innovation department. Secretary Carter talked about a few this morning. My piece of that has been something called Better Buying Power 3.0, which is the most recent iteration of a set of initiatives that goes back to the Secretary Gates' days early in the administration. The first iteration was about cost consciousness and efficiency. The second iteration was about building up our professionalism, our ability to make good judgments about the things that we do in acquisition. And the third one emphasized technical excellence and innovation. So we have a whole number of wide range of initiatives that include how we work with industry, how we bring commercial technologies in, how we plan for the future. All of these are pieces of the same mosaic. So we're focused on this on any one of a number of different fronts, whether how we manage intellectual property, how we work with industry, how we encourage IR&D, how we transition things, how we use modular designs. There are a whole host of things that we're doing designed to get technology, and advanced capabilities fundamentally to our warfighters faster. And I think as Secretary Carter talked about, I think Secretary Work also, agility and flexibility are very much a part of that. So we have created some new ways to do business with the department, particularly in the earlier stages when we're doing risk reduction and demonstration and development that allow us to contract more flexibly. All of these, again, are parts of a much broader effort to try to get capability to our warfighters as quickly as we can. I'm going to close my opening remarks on kind of a negative note, though. All the things we're doing are creating options for future administrations or future Congresses to fund. We are not fielding capabilities in many cases. We're doing early stage risk reduction experimentation. We're building prototypes, and we're giving the operators a chance to try things out, and we're moving technology forward. It's great for the industrial base. It keeps engineers employed doing cutting-edge things. That's good, but it is essentially buying options for future programs that we would have to fund, and that's the problem. If you look at what we're doing with SCO, if you look at what we're doing with DIUX, if you look at what we're doing with the services and the labs and so on at DARPA, these are generally things to get us ready to have a funded program for development for production and production itself. They are not that. That takes money that we don't have, and that's what keeps me awake at night. If you look at the structure of our research and development accounts, we are now spending more, and we will over the next few years, on risk reduction than we are on new product development for production. That's a reverse of the way the situation ought to be in a healthy new product pipeline, but that's the situation we have. It's right to do these things. It's right to do the demonstrations. It's right to get ready and provide options for future administrations. But if we don't get out from under the threat of sequestration, if we don't get to reasonable defense budgets that are consistent with our commitments around the world, we are not going to be able to field these capabilities. I'll close with that.
Thank you. Leanne, I would love to hear your perspective from a broad overview initially on making the third offset type capabilities that you from your industry seat have seen described by the government implemented into systems.
Well, thank you, Andrew, and thanks for everyone for allowing me to be here today. It is quite an honor. I think it is safe for me to say that all of us are here for the very same reason, which is to provide those men and women who are in the fight 24/7, day after day, to allow us to have these types of conversations, the ability to have an unfair fight, one that allows them to have the capabilities and technologies that will allow them to advance their position and know that the capabilities that they have will not be defeated by our adversaries. I think our challenge continues to be we're operating in a world where not only are the threats not lessening, but the geopolitical concerns continue to grow, and budgets, as Frank indicated, continue to be at risk. And that's not only here in the U.S., but that's with so many of our ally nations as well. And so what does it really mean for us as industry? And it really is about how do we embrace Moore's Law? How do we defeat Augustine's Law? How do we keep pace with the technology? How do we accelerate it? But how do we do it in a way that it is truly affordable and leverage the prototyping and the other activity that the third offset provides us, so that as we move into the future for future conflicts, our servicemen and women have the absolute best technology and needs that to address. There's 3 actual initiatives that the U.S. government has partnered with us on from an industry perspective, and I think they help enable the type of culture we're talking about. First off, with DIUX, the Defense Innovation Units, whether it's in Boston, Silicon Valley, or the newly opened facility in Austin, provides an opportunity to talk to some non-traditional folks about how they might bring not only technologies that they're developing, but business models on how they're developing it. And this is a really great opportunity for us as the traditional primes, because it is expected that we're innovating. And this is a way for us to partner and to, quite frankly, have a more richer dialogue and conversation about what the art of the possible is. Dr. Will Roper in the Strategic Capabilities Office, that is going to allow us an opportunity to look at what we've traditionally built and look at it in non-traditional means. So many times why we build something and what we understood the original purpose ends up being transformed over time as that capability is best understood, or someone who's perhaps not in that specific space has an opportunity to play with it and then go utilize it. We are extremely excited about the opportunity, and we as the Boeing company have submitted more than 40 proposals specifically in terms of technologies, products, services that are out there today that we think have value at a larger scale and perhaps in a differentiated format from when they were originally developed. And then finally, I would be remiss if I didn't also mention the Space Enterprise Consortium, which is breaking down the barriers for non-traditional and small business and allowing an opportunity for the traditional partnerships and primes to work together. And I think it will also change the conversation in the future as we look at going to the moon, Mars, and beyond. But I also think it's important to know that industry is all in. I am confident sitting here speaking as the Boeing company CEO for our defense business that we are all in, but I also feel very comfortable as a member of AIA and with my the partner companies and industry teammates that we truly believe about giving that advantage to these servicemen and women, because this is so, when you boil it down, that's what this is really all about. The technology is interesting. We need to continue to advance it. We need to embrace it. We need to look for opportunities to excel with it. But if it doesn't benefit those men and women who are putting their lives on the line for us, then we're really not doing our job. The other thing is we can get, I would say, fascinated with the technology, but I believe there is equally as much innovation in business models, in operationalizing, and also in creating a culture that allows us to recognize that perhaps every innovation doesn't result in something, but it creates an opportunity for us to experiment, fail fast, and move on. And that, I think, is also critically important, and I think the third offset strategy supports that. But then finally, when I bring it back together, I think this will not happen without strong leadership. Strong leadership by the department, strong leadership by industry, strong leadership by all of the supply chain, as well as strong leadership by us as a community, working together and collaborating, because we need to be able to show that we truly value the most important thing, which is ensuring that those men and women who are in the fight have what they need and help us retain that dominant position for both the U.S. and its allies. Thank you, Andrew.
Thank you, Leanne. All righty. I know we've talked a lot about fielding and implementation, and DARPA works at an earlier stage of the process, but of course, there is a heavy technological component to the third offset discussion. So feel free to speak to fielding and deployment if you choose, but also feel free to focus more on the technology end if you want.
Absolutely. I think most people here know that DARPA's mission is to make the pivotal early investments in breakthrough technologies that fundamentally change opportunities for national security in the future. And when we look at DARPA's history, everything Frank described about the second offset, from stealth aircraft to precision-guided munitions to battle networks, all of those things were first shown to the world and to the services by DARPA. More recently, if you look at what we've been able to do to show the Army what's possible with sharing tactical information by leveraging the personal electronics revolution, or you look at how we've used big data to roll up billions of dollars of terrorist financing in theater, all of those are examples of DARPA playing its role of showing something that is not just incrementally better, but radically different than what we've been able to do before. And our piece is a very small piece. We're about 0.5% of the Defense Department. We're only one part of the science and technology investments in the department. And none of these big things happened without the rest of the department and the services and the industrial base doing an incredible amount of hard work and investment. But that small piece that DARPA, that small role that DARPA plays, continues to be absolutely essential, because the problems that we face in the future are not ones that are going to simply recede away with incremental solutions. We are facing some extremely difficult challenges, and the third offset, of course, focuses on our emerging peer adversaries. The Undersecretary's really outlined exactly why those challenges, I think, are so dangerous out ahead of us. But I think it's just worth noting, even at a third offset conference, that that's only one of the many things that the national security enterprise has on its plate. And so we, of course, need to continue to understand how we're going to deal with terrorism and violent extremism and the emergence of different threats from different kinds of players, the cyber threat. When you think about what happened last Friday from the Internet of Things being harnessed in order to take down a lot of the Internet, just a very small example. So we look across that entire landscape at DARPA, and when we think about what's coming down the pike, huge number of different very interesting technologies, and we could spend as much time as anyone would like talking about any of them, because we believe that what's going to be necessary in this next generation of military capability will require some fundamental rethinking about the architectures with which we fight in the air and on the ground and in space and in the maritime environment. It's going to need some radical new thinking about how we operate in the spectrum, how we operate in the cyber domain, how we operate in the information domain, a place we're not actually that comfortable operating, but which has become more and more integral to what conflict looks like in modern times. But instead of focusing on that, let me just make two comments that I think maybe pertain to the topic at hand for this panel. And one is about the industrial community, and one is about what's happening in the department. If you look at the technology environment in which we're doing our jobs today, with very powerful, very fast-paced commercial global technology that is not just available from the United States to the rest of the world, but increasingly being invented and developed around the world. By the way, that's great for the planet. It just makes it a little harder for us to do our jobs here in DoD. In that environment, what seems very, very clear to us at DARPA is that it simply won't work to lock ourselves in a skiff and invent everything, sort of isolated from what's happening commercially. Equally, it simply won't work to hurl COTS at the adversary, because the adversary is going to hurl that right back at us. And what we see over and over again in our programs is that when you can look across what is happening from deeply classified, very specialized military components and technologies to what is happening commercially. And then when you can sometimes deeply integrate those, sometimes inform one with the other, that's when really big things are possible. And just two very easy examples. A few years ago, we set out to fundamentally change the way we do close air support. We knew there had to be a better way than paper maps and voice communications. We could have said to the defense industrial base, please take GPS and a touch screen and communications, and could you make us a device? But we actually could just go buy that for a couple $100 because building on many years of defense investment, all those components had been integrated for commercial markets. Of course, we all live with these marvelous tablets and smartphones today. Think about the billions of dollars of private commercial capital that gave us that technology. Now, so we started with that, but you don't change close air support by handing that to a special operator and saying, have a good day. What we had to do was take that starting point and add to it the encryption that we need, add to it have it connect to military radios because you're operating in places that don't have 4G. And when you do all of that, and then when you work closely with operators to develop new ConOps, number one, you can make close air support much more precise and close much more rapidly. But over time, as we take those same technologies into multiple platforms, we can not only make close air support better, we can actually make it transform into a capability that allows the warfighter on the ground to control the fires from remote places that will protect those individuals. And a revolution can start with something as simple as starting with these commercial tablets. A different, but I think also powerful example is if you look today at the most powerful RF arrays that the Department of Defense is building. These RF arrays are the envy of the world. We can see farther, we can see more targets, we can see with greater accuracy than anyone on the planet. And the way we are doing that is we are taking the advanced commercial silicon technology to build the digital back end, and then we are deeply integrating it with a very specialized front-end technology. The gallium nitride technology that started at ONR, was driven by DARPA, is now in the defense industrial base. It won't be protected from the rest of the world forever, but we do have this period of time where we have a unique protected DoD secret sauce, and when that's deeply integrated with commercial technology, that's how we get this huge advantage. So, I think we need to get out of this sort of, is it just going to be COTS or is it just going to be the defense industrial base? Very much as you were saying, Leanne, I think the connections are going to be very, very vital going forward. And I'll just finish by reflecting on what's happening from my vantage point inside the department. When I showed up at DARPA a little over 4 years ago, my boss, Frank Kendall, was saying, look, exactly what he just said here, the world has changed. We've been busy fighting ground wars, but the rest of the world hasn't stood still. They've been watching exactly how we fight since Desert Storm. We have got to get on it. But I have to tell you, 4 years ago, when I talked to our colleagues across the department and in the services, I would tell you they were completely chewed up with the ground wars and the conflicts that we had on our plate. And the capacity to think and start moving in that direction seemed actually terrifyingly limited to me. We've made huge progress in the last few years with the leadership in the department. And today, the enthusiasm with which people are reaching for these advanced challenges, I think, is very, very encouraging. At DARPA, we like to joke that we now see the services with PowerPoints and videos where they stole those ideas from us, and we love that. That's great. But I also think it's important to note that PowerPoints and videos are not yet capability, and so all of that heavy lifting is still very much out ahead of us.
Shahar.
Thank you, Andrew. So first, thank you for inviting me and giving me this opportunity to be part of this honorable panel. So I can imagine you're not familiar with RoboTeam, so maybe I will just say a few words about who we are. And to be completely honest, I didn't know what third offset is. I just heard it from customers that's saying to me, RoboTeam is a great example of how you implement this approach and, of course, the better buying power approach. I can tell you that recently Miss Heidi Shui joined our team, and she's saying that to me, exactly the same thing. You are a great example of how to do it right, And we didn't write any document. We just did it because we thought this is the, the right way to go. So a few words about RoboTeam. We opened the company not too long ago. It looks like I was born in RoboTeam, but actually it's been only 6 years, and we do what we do about 4.5 years now. We are developing small unmanned ground vehicles, small robotic systems for all kinds of military purposes. And I'm proud to say that we are today probably the #1 provider of this kind of systems in the world. We have systems all around the world, of course, with the U.S. forces, working very closely with the U.S. Air Force, U.S. Army, with the Israeli military, of course. We won some big programs, and as you can probably imagine, many people are asking me, so what's the deal? How you did it so fast? Like, how you moved from PowerPoints to systems in Afghanistan in 18 months? How you do it? So we are very different. We are, in a way, a Silicon Valley type of company / Israel startup nation company. And in this traditional conservative, market. And I'm not necessarily talking about the technologies itself. I'm talking about the general approach. And I was trying to think about it, and we are doing 4 things very differently. And I think that the customer like it and appreciate it. So the first thing, we have a direct communication with operators and end users. Regardless to the fact that 75% of our companies are like veterans, ex-military, we are listening to the soldiers, and we are not going to wait for this need to become a document, to become a requirement, become a specification, become an RFP, become a contract, because if we will wait, it will take 3 years, and it will be just not relevant anymore. And we are listening to the soldiers and just do it. We are investing a lot of money of course, in our standards, a lot of money in R&D, in internal R&D, and we don't necessarily expect someday the government to come to pay for it. This is how we are building the company. The second thing that we do is we are making sure that everything will be very, very simple. We can't expect operators, and I'm not talking about the expert, I'm talking about the big military, the army, the infantry, maneuver forces, to use complicated systems. It needs to be simple. We need to do exactly what Apple did with the iPhones. We need to do it to ground robotics in our case. The third thing is speed, and I heard it in the earlier sessions. We developed a system in RoboTeam to do short cycles of development, and it takes us few months to get an idea to the field. So we call it the 4-month cycle. We are thinking about it, doing, in RoboTeam, each effort is a crash effort. This is how we look at it. It's like a war zone in the company every day. But this is what allows us to plan for a month, to execute about 2 to 3 months, and then test and evaluate and push it to the field as soon as possible, even if it's not 100% ready. And this is very important. This allows us to provide solutions very, very fast. We feel that this is the area of the fast companies and not necessarily just the big traditional efforts. And this was a key thing. And last is, of course, price. I can tell you RoboTeam participated in several big programs. We won competitions based on technical evaluations. I spent many, many hours at NIST doing those tests, and we won technically and still provided systems half of the price of our competitors, just because this is the approach, and we are not losing money. We are completely okay. And this is the right way to go. I would just finish with a short story. Mr. Kendall came to visit us 2 years ago in Tel Aviv. It was doing protective edge operation, and this was a great example to what is really RoboTeam is all about. Operators Gaza from Tel Aviv, it's about 1 hour drive. It's not Afghanistan to DC. They're driving in the morning, saying to us, this is the problem that we have with your systems. This is what we want to change. This is what we want to modify. We're saying to them, okay, come back in the morning, working all night, providing solutions, simple solutions to the field a day after. Now, of course, this is an extreme situation, but this is the approach, and this is probably our implementation to the third offset approach.
Thank you, Shahar. Pierre, Dr. Carter this morning talked about that the American way is to work with industry to create capabilities. What he didn't say is that money makes the world go around, but of course we know that that's also a true phrase. And in the United States, when you're trying to get industry to build things, it's investors that provide the money that make it go around. So I'd be interested in your perspective on kind of an investment community perspective on this, and then anything else you'd like to share.
Yeah. I think for sure there's the dawning of the realization that, at least amongst the investor class, that this is something that's relevant. And if I had to sort of make an observation, though, about the current state of the debate and the discussion, there's a couple of things to note, right? The first one is that in the end, we have an ecosystem of innovation, ecosystem of companies, right, and an equivalent ecosystem of investors that support and reinforce each one of those. And frankly, I think the mastery of the complexity of that ecosystem is what will give us the advantage. And I get a little bit worried when you see reports or analysis or pieces that come out of the think tank world that zoom in on one element or very sort of one size fits all, right? Because in the end, if you take the three axes of what's inside this ecosystem, there's actually an ecosystem of innovation, right? Everything from disruptive innovation, which is the sexy part, that's what everybody loves to write about, why aren't we disruptively innovative? You've got incremental innovation, that's probably 80% of what we do and should be doing. I don't know how to phrase this one, but essentially combinatorial innovation, what Arati sort of mentioned, right? And what CSO is all about. How do I take existing things and make them more clever? And in fact, if you think about it, more so I think than disruptive innovation, that's really where you've had the huge revolutions, right? In the 30s, it was the combination of the radio with the tank that got us, and the ConOps on how to do it. That was the real sort of trick. And then there's, as Leanne mentioned, there's business model innovation, right? And that tends to sort of fall by the wayside a lot, because for a lot of people, that's boring, that's not sexy, who cares about that kind of stuff? But there are things that are underway in business model, and also on top of business model also include process innovation, manufacturing innovations that are going to be really revolutionary, particularly with 3D printing and others that can change that. So, and each one of those types of innovation has a different set of companies that go along with it. So the other axis in terms of ecosystem is we have a massive ecosystem in terms of the industrial base. And once again, I think there's a lot of focus on Silicon Valley and the commercial world and others, and yet we do have a defense industrial base, I think, that plays a critical role in it. And you heard the question earlier this morning as well, a global partnership base. So I just came back from Japan a couple of weeks ago. For example, right, one of the biggest shifts in the defense industrial landscape over the last 40 years, I believe, is the opening up of the Japanese market and their changing of their export laws. And if you think about Japan, on the commercial side, what are they working on the day-to-day on the commercial side? They're working on automation, robotics, et cetera, because they have, as a nation, a need for those things. Who's the number one users of UAVs commercially in the world today? The Japanese. 4,000 of them flying, doing precision agriculture today, right? They're working on things for robotics because of an aging population, et cetera. And so if we're going to be successful in this, the ability to tap across the entirety of that ecosystem, everything from the startups like RoboTeam to the Boeings of the world, to the international. So second axis. Third axis is there are technology life cycles, right, and industrial life cycles. Everything from early entry innovation phase, think about the aircraft industry in the 1920s or the UAV market today, all the way to mature sort of technologies, industrial bases, shipbuilding. And the ability to sort of tap into each one of those for their different level of innovation, as opposed to, once again, just zooming in as one of them, I think is critical. And so how do you get all three axes to work and be coordinated is going to be a huge challenge, right? Which then brings me to my second point. The issue is about challenges. I'm struck by how quickly we have moved to discussions about technology when it's really about the challenges. We were just talking downstairs. When we were doing the first offset, nobody was calling it the first offset. They were just solving a problem. Nobody was calling it the second offset when we were doing the second offset. They were solving a problem, right? As Vago Muradian noted, the precision revolution came about because we had a problem in Vietnam about how many airplanes we needed to hit those bridges and how many missions I had to run, and it was how do I get more precise and do it. The problem with stealth was how do I penetrate Soviet, ever-increasing Soviet air defenses, and nobody came along and had stealth ahead of time and said, I've got a technology that can solve your problem. I had a problem that was then searching for a technology. I would argue if third offset is to sort of truly meet the goal, and the best way to incentivize industry is don't tell them I want a better blank. Tell them this is my number one problem. You go out and figure out how to solve it, right? Which is how sort of the approach that you come at, because the answer could be anything. That we don't know. And ultimately, then the third issue that comes along is the analytics that we then use in our system to measure which one is right or wrong, right? The old force-on-force models are not going to work when you're trying to insert all these new concepts and new technologies. And so there's as much, I think, a revolution in the analytics. This is a really geeky sort of corner kind of topic, but I would submit to you that unless you get that right, you're not going to be able to run through all the analysis that will tell you this is the right one to field or not. In certain areas, I have an actual war to fight that is acting as a substitute for those models, because I'm trying it in the field. In other places, I won't have that. And ultimately, the side on incentives, it's actually a reassuring thing that people are even using that word, right? I was struck by in a lot of the acquisition reform studies of the last 20 or 30 years, you never saw the word incentives. The mere fact that we're using the word incentives, I think, is exactly right, because I've been struck now looping back to the investment world, by how many investors these days are starting to say, well, where's the new growth going to come from? When is the industry going to invest? And actually, industry sitting there saying, I am more than happy to invest. We just need the right incentives in order to sort of to do it, because ultimately they are businesses. And the incentives are tied to now back to those issues of where are you in the life cycle and other things. If you're a mature business, my incentive is more about cash flows and return on investment and what I get. And if you provide the right tipping point types of incentives, you will get companies to do share lines and innovate on the process side. For a lot of startups, their incentives is less about margin. It's pick me, right? Make me the dominant standard, right? And then I'll make up the money later on, right? Which is why that issue about intellectual property was so critical. And so this issue about, at least the fact that we're talking about incentives, I think is great. But once again, this is another place where one size does not fit all, and you start to do that. The DARPA prizes and the X prizes are actually a perfect example of incentives, right? The DARPA X challenge for the robotics one, there were 100 companies, I think, that submitted, right, to do that robotic challenge 5-6 years ago. We actually surveyed and polled a whole bunch of them to find out how much money did they spend. For that $1 million prize, there was about $85 million set against it, all because each one of those guys thought they would get the $1 million, right? So that's a clever way of doing it. This will never happen, but I bet you if you were to put a $10 billion prize, first company that goes, single stage to orbit for $1,000 a pound, I could get at least 3 companies to chase it, right? And fund it. Now, Congress would never approve it. That would never get past the Pentagon. But there's a notion, again, of, help me prove it. And I think it's those kinds of innovations also sort of need to be thought of. And you heard Dr. Carter begin to talk about more of them. That's sort of feeding into the system that helps. But mastery of the complexity of the ecosystem and making sure we don't do a one-size-fits-all, I would submit to you, is one of the key elements of getting from here to there into fielded systems as well.
Thank you, Pierre. Well, this is one of those exciting times as a moderator, because the first 2 panels probably knocked out about my first 4 questions, and now this panel has probably knocked out about the next 5. So you can join me in winging it here. I'm going to ask a small, about half the time we have remaining, some questions from me, and then we'll open up to audience questions after that. So I'm going to modify where I was going to start. I was going to start with the long-range research and development plan, Frank, which you mentioned. But since Pierre basically undermined that by saying we shouldn't start with technology, we should start with problems, and because Shahar talked about how he starts with the problem, I'm going to try and work those two together and get some response from the panel. So if we're trying to start with problems, and I really, Shahar, took note of your point that, to do it the way you do it, you can't afford to wait for the written document that says, I'm going to describe in all the infinite detail to you the problem that I need solved. You need to get it much faster than that to be able to respond in the time frames that you're responding on, and I'm interested in the possibility of doing that on a larger scale. So if we're trying to start with problems and get at problems before they've been formally put into requirements documents, that's a challenge for our system. I think that's a challenge for industry because there's a lot of risk in that. It's a challenge for the investment community because the return on investment is going to be pretty unclear when you don't know if the customer is going to commit to it or not. Dr. Henry made a reference to that in one of his questions. So how do we how much risk is the system able to take in terms of identifying these problems, beginning to work solutions for them before we've formalized requirements in the traditional sense? How much risk can we bear in that process in order to get to that more quick innovation that I think has been a goal that's been identified? Would you like to start?
Andrew, you raised a really interesting question. I do think that the problem, if you will, in terms of the military problem that we're faced with is reasonably clear. We have reasonably good intelligence on the capabilities that potential adversaries are building. And in some cases, we've seen them put into operation. It's pretty simple. The technology that they're using is technology that we have, and maybe we have, in some cases, slightly better technology. But it's the ability, as I said earlier, to target some of our systems. All weapon systems ultimately become obsolete because somebody figures out a way to defeat them. A better idea comes along. We have dependencies that have been obvious for decades in terms of what we do. We also have the problem of having to project power very far from the United States. And that brings with it a logistics requirement which can also be attacked, that logistics chain, if you will. It brings with it some time and distance problems in terms of how fast we get forces to where we need them to be. Very early in my career, I served in Germany in the Army, and we used to do exercises where we tried to determine whether we could really get 10 divisions on the front line in Europe within 10 days. That was our requirement. The problem we were trying to solve, the second offset strategy was actually designed for, and people are right, we didn't call it that. It was called follow-on forces attack. There were different versions of it. It came out of some DARPA work, something called assault breaker, was Soviet armor, which was massive in numbers and already on the battlefield when the war started. And we, of course, had to get our capability there. We thought we could fight the first echelon of Soviet armor more or less to a draw, but the second echelon we just didn't have the forces to deal with. So the follow-on forces attack, which relied on wide area surveillance systems like JSTARS and precision munitions that were very efficient, and it's always about competitive advantage and efficiency, whether it's a business or a military. That was what we tried to achieve. That was the problem we were trying to solve. We solved it about the time the Cold War ended, but we demonstrated how well we had done in the first Gulf War. So the problem we're trying to deal with now is not just one major threat in Europe, but potential adversaries in the Pacific and essentially an air-land theater, and potential adversaries again in Europe, more of an an air-sea theater in one case and an air-land theater in another. But all of these theaters now have dimensions which include space, cyber, and electromagnetic spectrum as domains in which we have to fight. We still have some advantages in some other domains, undersea in particular. So that's our problem. is and Secretary Carter he's talked about in his budget last year, the 5 things we're trying to do simultaneously. You know, deter conflicts that involve adversaries in the Pacific, adversaries in Europe, near-peer competitors, basically, as well as states like North Korea and Iran, which could be problematic, as well as to fight ISIL. So we're overstretched in a way, trying to do all of those things. They're very different problems. So that's what we're trying to deal with. So as much flexibility as we can have in terms of what type of force we buy, and getting things forward quickly, getting combat power moved from the United States to where it needs to be, is a big part of the problem. It's multidimensional. It's really a lot to it. Also, support to our allies. You know, it would be nice for us to back up and fight from further away, but some of our allies don't have that option. They're already on the front line, effectively. So it's that whole spectrum of things. The ideas that we've come up with, I think, rely on emerging technologies that we see having a lot of potential. I think we're all concerned that many of those technologies are coming out of the commercial world, and therefore they're available to our adversaries as well. And that makes it something of a race to get them into military applications and then to keep refreshing them and to stay ahead. I think one of the things that I've seen in the intel is that the lead time between when the U.S. does something and somebody else develops a similar capability has shortened quite a bit. So while we may still be ahead, something like the F-35, for example, which is a world-class weapon system that's going to be, I think, the world-class weapon system for decades. But other people are trying to emulate that and come up with a capability that's as close to that as possible. And the lead time between us doing our system and someone trying to do something similar is less now than it once would have been. And that's because, again, of the globalization, the leveling of both technologies and the resources that people are able to put into these systems. So there is no easy answer to this. It is incredibly multidimensional. I thought Pierre gave a pretty good rundown of some of the different dimensions of it. At the end of the day, for me, it's going to be about the resources we can bring to bear and the wisdom of the decisions that we make about which investments to make. Right now we are starting a lot of things. We have got a lot of things in early stages which are relatively inexpensive. We're going to have to pick and choose because we can't do all of them in terms of actual field of capability. I kind of share Pierre's thoughts about modeling and simulation and analysis. We need to resurrect an analytical capability that we used to have in pretty good shape during the Cold War, because we were in what we all recognized as a very direct competition then, where we needed to be making better decisions and we needed to be making them faster and doing a better job of allocating our investments. And so we did a lot of work to make sure we made good investment decisions. After the Cold War, I think a lot of that capability atrophied. It needs to be resurrected. I think Bob Burke and I have had a number of talks about this, and we need to do some things to restore that. It is true that our current models need to be upgraded. I don't dispute that, but we can upgrade them. And I think our computing capabilities and our analysis capabilities should be much better than they were at the time of the Cold War, when they were relatively crude, but still helpful to decision making. I think the next administration has its work cut out for it. It has to deal with both the question of resources and getting adequate resources for the department, and it has to deal with the question of making these decisions. Because the demos that we funded, even if we fully fund them and get to do them all, will lead us to a point where we have to decide which things to make major investments in. And that's going to be hard, because it's going to be very difficult to get the funding to do even a minor subset of those things and to carry them into field of capability.
Leanne?
I'd like to address the perspective of how much risk is industry really willing to take. And as Pierre highlighted, innovation comes in many forms, whether it is true disruptive, incremental, or some large moonshot, as we call it, as you know, you're developing that next big horizon. I'll speak to the Boeing company. You know, if you look at our public financial records, you'll see on the Boeing defense side, we spend well in excess of over the past few years of $1 billion a year in internal research and development. What we want to do is invest in those things that mean something to the customer community and to the department, so that we invest smartly and so that it does have an opportunity to see the light of day. And those investments aren't all $500 million investments and we just do two things. I mean, it is a compilation of multiple projects in the tens of thousands that we look at and we try to address along the different lines in terms of incrementally improving products that we have today, partnering with another company where we can bring our technologies together and reinvent it, and or if there is what we perceive based on conversations we're having, a new threat that we are out addressing, we're willing to invest in that as well. And what you'll also find, and I think you've heard many members from industry say as well, not all of those ever result in a program of record or any type of financial reimbursement. But the second order benefits of doing that is the capability and technologies that we get from our engineering talent and our technology, how we partner with DARPA, and where we specifically insert and bid on certain technologies that we think are going to advance, perhaps not in the first 5 or 10 years, but perhaps generations later. And I think it's really important to know industry has not shied away from investing. Industry has continued to be providing a leadership role and saying, we are committed, we are all in. What we ask is that partnership and collaboration so we have better insight into how we should best spend our funds so that it provides the result that we're all looking for.
You asked the question about, how do they take risk? Actually, it is such a different investment pitch when a company comes along and says, oh, I've invented this great technology, or this doodad, and you say, okay, well, does anybody want it? I'm not sure. If I'll just hire some good BD guys, as opposed to somebody who sits there and says, I was a customer, or I know the customer, and this is the problem they want to solve, and I just need some money, and it's going to, it is such a fundamentally different. So I would submit to you if you were to go to a military servant and say, I've just solved your toughest problem, they will find the dollars and they will find the contract vehicle in order to get there. And that's been proven over and over again. So that's why I think the linkage of the two. And we had it in the Cold War to the extent that there was this, the fact that the Cold War was simplified from the perspective of what was the overriding goal? Beat the Soviets. Got it. It helped the industry sort of self-organize itself to the extent as long as I was roughly in that direction, I was in the right direction. And then end of the Cold War, it kind of unleashed everything, and there was a lot of, well, what do you really want us to focus on? The war in particular did. I think that's in some ways, I see the using of the third offset sort of commentary to try to create this self-organizing principle, but ultimately I think there's another set of, you have to go one more level down to really operationalize it from any one individual company's of, what role am I going to play and how do you want me to do it? And if one possible macro one is, each of the other two offsets were ultimately also about scale, right? I don't want to do 1 million soldiers, so I'm going to do nuclear weapons. I've got a tank problem. We have a scale problem again, right, in terms of where the adversary, Frank mentioned those high-value assets, where they're targeted, and that scale problem goes all the way from the high-end fight to the fight, the counterterrorism fight of today. How do I spot the one person out of 1 million, right, the needle in the haystack? That's a scale problem, let alone the haystacks turning into needles, right, the radicalization problem. So I think in some ways this issue of how do we deal with this new problem of scale is one of the, is at least at the macro, but now it needs to kind of devolve into individual problem sets.
I'll make a comment about the situation we're in and risk, and a little bit about industry and how they see it. One of the things we don't have yet, we're trying to get to it, is a well-defined operational concept for the future. Once we have that, then industry knows where we're headed, and then industry can invest to try to fulfill that operational concept. We know we like certain features right now for the future. We know we want to exploit certain types of technology, but what we really don't have is a well-defined operational concept that integrates those things together. The follow-on force attack suite of capabilities was a well-defined operational concept. We're not there yet. So that's one area where industry can certainly help us now in trying to help us define that, because I think it's one of those sorts of things that when operators see it, they'll recognize it, say, yes, that'll work, that's what we can do. They're working on it too. There's a lot of innovation effort going on within the services to try to do that. One of the hardest things for a military service to do, though, is to fundamentally change the way it does business. Most of the time, what services will do is they'll take a new technology and they'll use it to take the way that they're currently doing business and to do it a little bit better. So they'll take the current structure of assets that they have, basically their capital structure, and they'll enhance it. I'm afraid that given the threats that we see, that's not going to be adequate, that we're going to have to make more fundamental change than that. And historically, when those changes have come, they've come from people who have lost wars, who in defeat have really revisited how they did their business. We're a very successful military at the moment, and so it's harder for us, I think, to re-examine some of those fundamentals. So that's a risk, that we won't be willing to do that. For industry, it's pretty simple. Industry is trying to figure out where we're going to spend money. And if they can offer us ways to spend money that are attractive to us, then you will. And I've talked to a lot of CEOs, and different CEOs for different companies are making different decisions. Some, a minority, thankfully, are saying, I don't see opportunities, so I'm not going to invest. There's not too much of that going on. Others are saying, I'm going to invest, but I'm going to keep it modest because I don't see specific opportunities. I like to get a clearer picture of the future. I'm going to invest in the things that I think are higher probability and nearer term. Then there are investments which are, okay, I'm going to help figure out what the solution to the problem is. I'm going to think longer term. I'm going to think more creatively, and I'm going to provide options to the customer and see if they'll embrace them. So you get a mix of those. For a few years, and to some degree still continuing, industry's been buying back its own stock. And you do that because that's a couple of reasons. One is because of the financial metrics that result from that. Another is because you don't see a better investment. What we need to do in the department is to provide incentives to industry to make investments of those resources into things that we're going to buy in the future. And where industry makes its money is generally in production and in sustainment. I'm talking about at the prime level. R&D plays relatively low margins because of the way we structure our incentives for R&D. It's about half of what we pay in production. So the name of the game is to get through R&D, get into production, and get to those higher margins, and then to do well also in sustainment and in foreign sales. So that's the business case that we have to create. We have to go let industry know what we're going to actually procure, and then they'll be more than willing to invest to try to win that work.
Sure.
With one more thought. We usually talk about commercial technology and markets as a place from which DoD might draw, but I think it's worth noting that sometimes that can create really interesting opportunities for the people we're working with at the development stage. And just to give one example, one of our space programs at DARPA, the experimental space plane, our objective there is, if you think about how we usually access space, it's years until you can get your asset on orbit. With the advances that have been happening commercially in recent years, I think that time is getting shrunk. It could be months, which would be fantastic. But really, if you think about what the big game changer is for DoD, for us it would be if you could put an asset on orbit tomorrow. Think about the deterrent effect on our adversaries when they think about taking out our space assets, if they know that we can be right back up there immediately. So we set out to build this experimental space plane. The notion is a reusable first stage that would put 3,000 or 5,000 pounds on orbit for a few $1 million, but critically be able to, what we want to demonstrate in the program is going to space 10 times in 10 days, something that's inconceivable right now. Now, we hope that that's going to be technically successful, but part of how I think the department could buy that capability in the future is not necessarily to buy that space plane, but just to use that service, because there will be many other commercial markets once that kind of very fluid capability exists. So, again, I think there's sort of many different dimensions, but when you start to see commercial opportunities that could give a defense contractor, perhaps, or any kind of firm, both opportunities to serve bigger markets that move at a different pace and do the things that are critically important for us. I think those are leverage points.
Shahar?
Yeah, I just want to give maybe some practical examples. So how the government is trying to find creative ways in the complicated acquisition process to do exactly what Pierre was mentioning. For example, challenge-based acquisition and approach that they call this approach buy, try, and inform. These are ways just to give the company the confidence. It really doesn't matter. It's if we will get it as an R&D contract, if they will just buy the systems, buy the service. It just doesn't matter. It's exactly like what Mr. Kendall said. We are not expecting to see the revenues from the R&D. We are expecting to see future from the R&D. And this is what we do. I would just mention one actually amazing program for us that we are participating in, Army is doing a robotic enhancement program, just short cycles of 6 months from proposals to soldiers using it in the field, and everybody knows about it. And I can say, as a small business, this is what we need, and this is what we want to see.
Great. I can't resist. I'm going to go quickly to audience questions, but I got one more thread that I can't resist raising because General Silva in the opening panel talked about, as did Deputy Secretary Work, talked about the importance of open systems architecture as a way, and you mentioned this, Frank, as a way to get capability to the field faster because you can sort of take out plug-and-play aspects of fielded systems without having to engage in an entire new development cycle. But I have to say that General Silva also basically called us out. And by us, I mean the acquisition community and industry, because he said, people tell me that they're doing open systems, that they've done it, that we're there. And then I say, okay, so this is what I want on your system. And they say, well, I can't do that. So I want to give this panel an opportunity to respond to General Silva's challenge and say, is it that we're not quite there yet? Is it that, so how would you respond, I guess, to that challenge?
I'll start, and I know some of my colleagues will have comments. We have, for many years, emphasized the idea of modular designs and open systems, and going back decades. It's been more so lately. It's been part of my Better Buying Power initiatives from day one. The large and expensive capital assets that we buy, think ships, if you will, or even aircrafts and ground combat vehicles, they're very expensive. We're not going to do a tech refresh on those things as platforms on 5-year cycles, or even less, which is the cycle at which information technology, for example, is moving out, which is just a year and a half or something. So how do you basically can keep those systems modern? Well, you do it through modular designs, and you do it through technology refresh cycles. And we're on our we've just done our second. We're starting to do our third recycle on electronics on the F-35, on the processing, because processing is moving, Leanne mentioned Moore's Law, very quickly. So we need to stay current. Our capabilities depend upon that. So the only way you can do that is through modular designs and open systems. Modular design gets you the ability to take something out and put something else in. Open systems gets you the capability to compete for that. And we want both. Okay. Now, industry always tells us that they like open systems, but they give us a lot of designs that aren't open anyway, and I did this when I was in industry, there's no secret about this, you basically want to retain market share, and one way you do that is you have proprietary intellectual property that allows you to do that and makes it hard for people to come in and displace you. So I think Secretary Carter mentioned this morning in response to a question. We've been trying to get that balance right. We put out a document that we've used with startups in particular about the fact that we're not going to take industry's intellectual property and give it away to your competitors. We don't do that. We do, in some cases, want you to give us the details of the interfaces between your system and whatever it's going to integrate into so that we can compete a future replacement possibly. We want that. Industry's quite creative at preventing us from doing that. I have a couple of CEOs who beat me up every time they see me because of something called the Common Data Link, which is definitely not common, and I'm continually write waivers for sole source procurements for it, to the frustration of people who have made investments to try to have a competing capability. So we have to work hard at this, and the devil's in the details, but that's the only way we're going to have technology refresh on reasonable cycles relative to the pace at which technology is moving.
I think I've been asked to comment. Okay. Well, I agree with what Secretary Kendall said. And also, as Pierre indicated, as we make these investments, there is that pullback in terms of what is the value that we're creating. And so it is finding that right mix, and it is finding that balance. And it is also actually understanding what the definition of an open system architecture is, because, well, it's very easy to use those 3 words and assume that everybody's using the exact same definition. It slightly varies by service, and not everybody's actually applying to the same architecture. So I think we're heading in the right direction. all of us are operate in a world and in an existence where we're continuing looking at new applications and loading them on and understanding the difference between how you are building in the infrastructure in what I would call the group A of an aircraft or a sub or a missile or whatever it may be, and then how are you switching and swapping in that hardware. But it goes back to defining the control points and defining the interfaces, and I do believe that is an area of opportunity for collaboration.
I think in the grand scheme of things, it's not a technology issue. Well, there's a minor technology issue to the extent of how tightly integrated is the technology to the platform, right? And or how short-lived. If it's short-lived, you don't bother, right? Because I can throw it away and restart the cycle somewhere else. It's really the business model problem. I mean, that's what's been holding it up. And maybe people are hiding behind the technology, but and it goes exactly to the thing that Frank mentioned, though, right? The cultural norm that has crept into the system over the last 40 years is take it on the chin in R&D and you'll make it up in production. Well, that creates all kinds of behaviors, right? So if you want to do a quote-unquote radical notion, what about making the R&D a viable economic proposition and put the margins up front there so you have less of an incentive to want to push it back into production? And actually, interestingly enough, the FAR embodies that concept. You're allowed to have higher margins on research and development embedded in the FAR than in production. So that central notion that I'm taking actually a lot of risk in the beginning, right? But yet the behavior for the last 30 years or 40 actually, probably if not more, has been different. But there's nothing that says we want to be that. And if we are truly in a mode of I'm in the mode of experimentation and developing technology, not producing things because I actually don't have the money. You know, I would say maybe we need to, that could be better buying Power 4.0.
Yeah, that's a great
I'm
point.
excited.
You want to go next?
No, I'm good. You're good. You go ahead. I'm good.
I applaud the idea. I'd be willing to pay higher margins in R&D. It's not that we set out to pay low margins. It's that's how it ends up. There's different kinds of R&D. They're usually for a weapon system in their life cycle. We'll do some R&D, which is government-funded R&D, which basically is on the merits of the technology that's being proposed, and it's competitive on the merits versus on the cost. So basically, we can pay a higher margin on that. That's earlier stage stuff. Then we get into the risk reduction phase, which precedes development for production. Okay, in the risk reduction phase, usually we'll try to carry multiple competitors, and we'll do a period of time, maybe 2 or 3 years, of risk reduction. And we'll often do that where we basically are buying to budget. We'll split that money up among 3 companies, and each of them is motivated in that case to spend all that money and maybe make investments because they're trying to capture the next contract, which is when we down select to a single contractor. That's the big thing for industry, is to win that. And that's going to drive performance, period. Trying to win that work and get onto both the full-scale development, EMD, and production. Okay, then we get into EMD, which is where the big development costs are. We get into it through competitive contracts. And industry bids to win. I have made the point multiple times with people who argue for fixed-price contracting versus cost-plus for development that you have to realize that industry has to win first, and that they're going to bid to win. They have no choice. They go out of business if they don't. So industry bids there to win. We try to set up incentives to prevent cost overruns and to prevent schedule slips. And that incentive for industry is in the profit they're going to make on the contract. And that's why margins are low. We don't set out to pay low margins. We set out to pay a reasonable margin if industry fulfills what it bid to us. So if you come in and deliver at the price you offer for full-scale development, you're probably going to make 10 or 15%. If you don't, you're going to make something much less than that. And we try not to be punitive in industry, but we try to create incentives that work, that basically get the behaviors that we want. Industry isn't trying to fail in its contracts. It wants to deliver the product so it can get to production and make the money. So there's no lack of motivation. So we can provide some incremental additional motivation by the way we structure that. Nobody likes to lose money. And we try to get realistic bidding through that. But I can give you any number of examples, particularly when budgets are tight and there are fewer new starts. The less business there is for industry to go after, to compete for, the more aggressively they're going to bid for it. And that's where we get the lower margins in R&D.
I want to move to audience questions. I know we've got a lot of eager discussion going on in the panel here, and I don't want to interrupt that, but I do want to make sure we get in some audience questions. We've got about 15 minutes left. So we do have microphones. For those of you who are here for Kath's panel, the same rules apply. One question. It has to be a question. And please do identify yourself and your affiliation as you stand to ask a question. So, okay. The first hand I saw was here, just next to the aisle. One.
I'm Dick Bonato with Institute for Defense Analyses, and innovation is great, but it's not very good if you don't implement. And we have a question here of, without funding, without support, how do we do the experimentation necessary to try the new ideas out and get them in the field? We used to have something called the ACTDs that was bureaucratized to a point where it was progressively doing less and less. How do we get the kind of experimentation we had back in the second offset into the system in a robust way?
Yeah, we're funding a lot of that sort of thing now. That's what the Secretary and Deputy Secretary and others have been talking about. That's why the 6.4 account is now going to be bigger than the 6.5 account, because we're doing more of that early stage experimental work. Let me say a little bit. I've lived the history of ACTDs. They were created when I was in the Pentagon before. And the original idea was a pretty good idea. It came out of Larry Lynn, who had an office across the hall from me. He used to be a director of DARPA. Larry's idea was that we have a pot of money. Initially, it was a few $100 million that we would use to do experimental prototyping. And this would give the operators a chance to experience something and understand its benefits. It would also, in some cases, provide leave-behind prototypes. So you build a small number of things, but if it's something like a command and control system, that's still a meaningful capability, even if you only have one of them, potentially. There were several problems with this in practice. Okay? The first problem in practice was that the systems that became ACTDs, the weapons concepts and so on, were things that didn't make the budget cut. They were things that people wanted to do, but they couldn't get money in their service budget to do. So they came and applied to get the money out of this extra pot of money. So we did the ACTD. We still didn't have the money to fund them, so we still didn't do them. Most of them ended that way, one or two exceptions. They also ended up in some cases with things that we fielded, but there was no sustainment provided for them. So we would give a COCOM, for example, a battle management system they liked, but there was no budget anywhere to take care of that. Now, the ACTDs haven't gone away. They changed their name. They became JCTDs. They're run by an office in the Assistant Secretary for Research and Engineering shop. They went for a time to much smaller projects, a few $1 million versus a few $100 million. And they had some success. I reviewed that portfolio not too long ago. They've done a lot of one-ofs where a COCOM commander might want a specific capability to put somewhere to deal with a specific threat that he had, and we gave him that capability. Or we did some battle management capability, some software we gave somebody to use. So there have been quite a few successes actually out of that program, but they're more one-ofs than they are things that got into production. In a few cases, they've been relatively low categories of acquisitions where we developed something that was procured by the service, a flight suit, for example, something like that. So anyway, they're still there. What we've done more recently with those is we've tried to get them back to being more significant projects, to take that amount of money, which is still pretty limited, and use it on things that have greater consequence than some of the things that they've been doing, if successful. So we're still doing those. We're also funding a lot of the things that Will Roper's doing, which are near-term demonstrators, very novel things that take existing systems and use them in different ways, combine them. And the Secretary talked about a couple of those this morning. We're also looking at some things. DARPA does a lot of this where we experiment with things. We do prototypes, if you will. So we're doing that. The problem, again, is getting it from that stage into full-scale development and in production. I want to make a comment about this because there are a lot of emphasis right now on innovation, which is very appropriate. We need innovation. We always need more innovation. There's also a lot of emphasis on taking more risk. Let me give you the other side of that, just so you have a more balanced picture. I sent an email to General Milley in the Army recently about this because I want to make sure he appreciated this fully. My observation after a lot of time looking at a lot of programs is that you got to be careful what you wish for, because when you get it, you may not like it. There are, and I'm going to use MRAPs as an example. MREPs are an example of a system we did fast. We had a battlefield need that was immediate. People were dying. And we went to industry and we said, okay, I need a truck that has a lot of protection on it. Give me that. And we got it. We took existing automotive components, we put them together, and we had multiple versions of MRAPs, of course, initially. We fielded them very quickly. It was a very responsive way. It shows how the system can react when it's motivated to do that. And industry will respond. I mean, we gave them a business case to do this for us. And industry responded very well. So we fielded the MRAPs. And we fielded like 25,000 of them. That was mostly for Iraq. And the MRAPs we fielded initially were big vehicles, and they had basically relatively low-cost non-dynamic suspensions, for example. Then as we surged in Afghanistan, we realized that those vehicles were totally unsuited for the environment we were operating in Afghanistan. And we bought another few thousand MRAPs with a more appropriate design, which was smaller, had dynamic suspensions, and so on. Yeah, and again, the right thing to do. We net bought about 30,000 MRAPs. We're getting 25,000 of them out of our inventory. We're keeping a few thousand. Right? Why are we getting them out of the inventory? They don't meet all our needs. They don't meet the spectrum of requirements we need for things we're going to keep in our inventory for a long time. Capital investments we make, we keep in the inventory for 20, 30, 40 years. So we are building another system called JLTV, and I'll contrast that with MRAP. It had its problems in the acquisition system. But most recently, I think we did a very good example of doing a best value based where we monetized best value, did a good competition, we did a good set of testing, and we've got a system that meets well thought out and fully tested requirements, including reliability, maintainability, and some other things, growth capability that we need. There is a contrast between these two systems, and the point is that both have their place. Doing a more deliberate process and making sure you're getting the right product is sometimes the right thing to do. Going like a bat out of hell to get something to the battlefield as quickly as you can is sometimes the right thing to do. If we're going to have something in our inventory for 30 or 40 years and we don't have an urgent need to get it there, I'd rather take a little more time to get the design right. And the note that I sent to General Milley, the point I made to him was that there was a correlation between time and quality. That if you want a higher quality product, you've got to take more time. Quality comes with complexity, and the things you get when you take more time are reliability, so that you have reasonable sustainment cost, maintainability, so people on the front line can take care of it, growth potential, cybersecurity, ability to work in a jamming environment, et cetera. These are all design features that some engineer, a lot of engineers, have to go design into that product. It's a higher quality product if you do that, but it takes you more time to do that design, and it takes you more time to test it, because you've got to test for all those features. So we ought to be a little bit careful about saying that we should do everything rapid and field prototypes. We've done that to our regret a few times. Global Hawk, a system we have in the inventory we bought quite a bit of, it started out as an ACTD. It was disastrous for sustainment, disastrous. And we canceled it at one time in favor of the U-2 because the sustainment costs were astronomical. Northrop Grumman got the message and worked really hard, made an investment to get those sustainment costs down. So they did a lot of redesign to get sustainment costs down. And then we made the decision to go the other way, and we flipped back because they had done that. The EKVs that we have for missile defense, that we feel that in a really big hurry to get some capability out in Alaska to defend ourselves against Korean missiles. We're redesigning those. They were done in a big hurry. We're rebuying that product because we didn't take the time to design reliability into it the first time around. So if there's time, sometimes it's better to take a little longer to get a higher quality product. But if there's really an urgent need and you have to go fast, and you accept the risk associated with that and you do it. And the trade-off is between time and quality and also risk, okay? If you're going to go faster, you're going to have more problems and more mistakes. I've worked on some programs that were given unrealistic schedules by the senior leadership. People will try. The way they try is they take a lot of risk. They get people on contract very quickly, don't think through the business deal very well. They have ill-defined requirements, so they just start writing software, and then you have a big mess on your hands. And I'm talking in particular about the Future Combat Systems Army program. Biggest waste of money that I've seen in the Department of Defense. $13 billion thrown away, no product came out of that. But we were told to go fast because there was I was working in industry at the time, and I was working with Boeing, by the way, because there was a very high demand on and largely I think for political reasons, that we go quicker. So you got to be really careful about this. You need to listen to the professionals about how long it will take to do something and what kind of a product you're going to get based on what kind of constraints you put on the schedule.
Shahar, I'm interested in your thoughts because you talked about literally doing overnight iterations, but you're also working with the services on capability that they're fielding that's going to be sustained. So how do you balance that, or how do you square the circle?
So the short answer for this question regarding using your system. So if you're not expecting, this is from my short experience, if you are not expecting somebody to pay for it, you will find the users that that will use it pretty fast. There are like many organizations that this is what they do, and personally I didn't have any problems ever to find users that will use my systems in training or in theater. By the way, this is all based on communication with users, and I feel the government is very, very open for test and try, in particular when the company is involved. This is also reduce all bureaucracy issues of giving equipment to soldiers. So for us personally, it wasn't an issue. I definitely think that exactly like the way the government solved the problem of fast acquisition. Because if it's exactly like Pierre said, if they need something, they will buy it pretty fast. I can tell you personally, we had an organization, we talked to them about 10 days ago for a certain problem overseas, and they bought equipment in about 3 days. So there are vehicles, there are contracts, it's not an issue. I definitely think that we need to find the way to do it also. I don't want to say R&D, but maybe on engineering effort, modifications, adjustments, integration, in the same way. The government knows how to buy equipment very fast. When it's to do some minor adjustments, so usually it takes longer from the acquisition phase. And if we will be able to improve it, so it will be. I think it will be a great benefit to the warfighters.
I want to chime in on this. I think, Frank, you just laid out in perfect clarity a trade-off that that you have to live with every single day. And I listen to your stories, and these are things that we talk about and are trying to think through at DARPA too, because Global Hawk and FCS are two great examples that started as brilliant DARPA ideas, and then look what happened, right? So I think when most of us in a room like this think about why it takes long, why there is that time and quality correlation, it feels like, I think most of Washington says, oh, it's the acquisition system. We're going to have to fix the acquisition system. There are some very deeply technical reasons for the reality that you described. And of course, when we see a technical trade-off that we don't like that's making us crazy at DARPA, we want to figure out how to blow that trade-off up and figure out a very different way to think about it. So one of the underlying technical factors in what you're describing, I believe, and all of us are living at the same time that all of this is going on in DoD land. We're also living with these sexy commercial products in our back pockets, and you know how easy it is to download the next app and everything just works. And so why can't it be like that? Well, there's a real technical reason it cannot be like that when you're talking about upgrading a complex platform like a fighter, for example. And when you peel back the layers, some of the technical reasons have to do with the fact that these extremely capable mission subsystems have to be tightly integrated together. Think about how the position, navigation, and timing system connects to how you do communications and how you do jamming, just as one small piece of it. What that means is that when you build those systems to begin with, you all are putting those systems together, and you have to build this, it's almost like hardwired spaghetti to link all of those things together, both in hardware and in software. And so it's actually, in addition to all of the acquisition things that everyone likes to talk about, there are deep technical reasons that you can't just pull something out and plop something else in and just have it go. Now, we also believe at DARPA today that there are some fundamental technology advances based on deep mathematics and new architectural ways of approaching these problems that could provide a technical basis. This feeds into all the issues you just talked about, but also into the whole conversation about modular systems and open architectures. You can imagine a future, and now we're starting, I think, to have the technical components to allow us to get on a path to a future where you don't need multiple years of people sitting around a table to refine a standard because the standard that you had didn't anticipate a particular future technical direction. You can imagine a future where these subsystems now actually can be not just plug and play isn't just sort of a buzzword, but it actually becomes something that you can do in an acquisition sense very, very rapidly. You could even do it in the field so that you can compose the architecture you need to fight that day in the field. And those things don't seem, they don't seem to match the reality that you're describing today, but I think those are some of the dimensions of technical innovation that we have to go after, because we can't really achieve what we need with the trade-offs that exist today.
One of the things we can do, and we can't always do it, is just use commercial products. The Virginia submarines combat system, for example, is very easily to technology refresh because they went with a commercial basis for that system. But they had the space and they had the other things necessary to allow them to do that. I appreciate your point about the acquisition system, because I think there is a perception in many places that the reason it takes us so long to do programs is the acquisition system. That is not true. What takes so long is doing the work. Okay, the reason the F-35 has taken so long is that we've had to write an enormous amount of software, and it was very hard. It had nothing to do with the acquisition system. We had to do an enormous amount of testing to test all those very sophisticated features that we put into that design. It was doing the work that took the time. And again, the contrast with MRAPs. MRAPs are a very simple design problem. Secretary Panetta's first question to me was, why can't we do F-35 like MRAPs? And my answer was complexity. When you have a much more complicated integrated design with a lot more requirements. So the first thing that you have to get right if you want to go fast, I can get that entirely out of the way if we need to. What we need to do is get the requirements right so that we're not asking for too much, so that we ask for something that's reasonable. And in many cases, I work closely with, I applaud what the law did last year, which gave the service chiefs a greater role, because the service chiefs are stepping up and getting more involved in requirements, which is where they can help enormously between the acquisition community, the requirements community, and makers involved. But if time is more important to you than cybersecurity, if it's more important to you than being secure against jamming threats, then we can get rid of a lot of stuff. But if it's still important to you, then we're going to have to take time to build that for you. Those decisions can be for too long on a time. But it takes us 2 years to get money to do all the things we have to do to have a contract, so that when the money, so we try to adjust, if you will, programs down. We work pretty hard at that. Is an illusion. That's really not what doing the work that Boeing do to design the product and test it and make sure it's ready to go into production.
Well, thank you. As you can hear, the other panel has let out, which is a subtle hint that we have come to the end of our time. I want to let you know that for those who've signed up for lunch, lunch is out there. There is lunch also on the first floor. So if you find it crowded on the second floor, and you probably will, look to the first floor as well. And please join me in thanking our panel for a great discussion.